Hello, this is Brian Cummings again with another Let's Mod video. This one we're going to be going over the basics of how to create your own materials and shaders for the Spark engine. And yeah, we'll be using Natural Selection 2 assets and stuff from Lafourche today. And I have in the past made a video about how to create your own materials, but that was before release, and since then we've switched to shaders. So I only recently learned how to write my own shaders, so I'm just going to show you the basics of what I learned, and hopefully from there you guys can create your own cool shaders and have fun with that in your mods. So first thing we're going to do is open up a material file from Natural Selection 2. Probably just open the gorge because I like the gorge, and let's take a look at that. And this is similar to the previous video. Mainly difference is there's a line here for shader, and then the format's a little different. But it's basically the same. We have pretty much just three different things to look at here. First of all, the maps that define the textures that are being used in this particular material. Like this is the gorge material. So on the gorge material we have an albedo map, which is this Models Aliens Gorge DDS, and that is essentially just this DDS file. And if you have the right plugin for Photoshop, you can open that up and just take a look. That's the basic gorge file. So if I wanted to, I could edit this texture and save it in my mod, and then maybe have a different name, or just I can even just save it as the same name, and then it'll be overwritten in the mod. And that's pretty much the easiest mod that you can do, is just like change the DDS file, or in this case you'd have to save it as a Photoshop file and then build it as a DDS. But yeah, I guess you can just publish the DDS if you know how to create one of those, and that would basically just change what you would see on the gorge for the albedo map. You could also like save it as like gorge or gorgles in my case, which was for my gorge race mod, and then you would want to change the gorge.dds to gorgles.dds, and then it'll look for that texture instead of the original gorge DDS texture. So yeah, that's just the basics of creating a map and changing it in the material file. And I've been over that in other videos, so we'll just skip that for now. The normal map and a emissive map and specular map, those are all just different maps that you would use. The other thing that we have here is a surface type. This is for aliens. Pretty much everything uses organic, and what the surface type is doing is just telling the game which type of surface material is, so that it can use the right sound effects and cinematics for that surface. So like if a gun is shooting the gorge, it'll use the organic cinematics and the organic sound effects for that hit effect. You can actually look at all the different types of surfaces that you might be able to select here by just going to your cinematics folder and look at materials, and these are all a bunch of different material types. So the common ones and the default, if you didn't have this line, would be metal. And if you look at metal, it has like a different cinematic for axe hits and bashing and biting and claw hits and gores and explosions and ricochets and all that fun stuff. And if you look at, we have these other ones. There's a thin metal. There's rock, which is very common in a lot of our models, and flesh and glass and hallucination has its own material, and some of these are only used in very unique situations, like deflect is only used in like ricochet and then a couple different things here. Umbra is very specific to ricocheting for projectile weapons, and yeah, the rest kind of have like the full complement of cinematics, and then the same thing goes for the sounds, but cinematics are easier to show you. So yeah, that's the different surface types, and I guess the last thing to show on a material file is the shader, and that's where we're going to get into a lot today in this video. So you can see here it's pointing to the models alien surface shader. So where would I find that? Be in models aliens, and that would be this one right here, this alien surface shader. I can open it up and you can see it's a bunch of code. Code here doesn't make a whole lot of sense if you aren't familiar with it, so we'll break that down a little bit in this coming video, but start with something a lot simpler than like an alien model. This one uses like special blend and overlay maps that are used for like blood and infestation and other fun stuff like that. The other, there's an alpha version, which is pretty much on all the buildings because they have like an alpha layer for where the bottom meets the infestation, so it looks a lot cleaner. There's also custom ones for the Marines, and in general though, you're going to want to use, like if you wanted to change the shader of the gorge to like use a Marine surface shader for whatever reason, I could do that by just changing this models to models Marine / Marine .surface shader, and then it will use that instead of alien. So you can do that for whatever reason if you wanted to. You can also use these default shaders, and the most common one in the game is got to be this level surface shader, because we have so many props and level materials that pretty much everything uses this surface shader. If it's like a model or a building, then it'll use one of these surface shaders. There's one with just regular surface shader. There's modescore alpha, there's underscore emissive, and alpha. And the reason these are all different is because let's say I have a model file that has an emissive map, but I'm just using this surface shader. Well, this surface shader doesn't look for an emissive map, so it will ignore the emissive map that you have in your material. But let's say this modescore, the emissive version of this surface shader, is going to be looking for an emissive map, but let's say that your material doesn't have one and you're using this one, it will it'll try and find an emissive map, and if it can't, then you'll start getting like console errors, and that's pretty common. So you typically, if you ever see anything with a console error, it's because it's missing a texture that the shader is looking for. So yeah, the common ones you want to use are these model files for like characters and buildings, and then there's a view model version as well, and then these level ones for pretty much everything else. There's decals as well, and then some GUI stuff, but we won't really need to worry about that right now. It's a little more advanced. And so yeah, that's a list of the basic shaders here in the core folder of Natural Section 2. And again, you could just change this here, but you gotta make sure that has the right inputs for the shader that you're using. Okay, so that's just sort of a rundown of like things you can do if you didn't want to create your own shader. But now I'm going to go into basically creating a new shader based on the wall shader that Max made for the LaFauche mod. And so let's go ahead. I'm going to open that up and show you what that looks like. that would be like, well, yeah, we use this exterior surface shader. So it's not as complicated as something like the alien model, but it does have some interesting stuff going on here. So we're going to go into that. I'm just going to save my own version because I'm going to create a new version from scratch for you guys. So we'll just do exterior underscore chops, and we want to make sure that we use the right thing there, and make sure that's saved as a surface shader. Yep, yeah, the right extension. So I'm going to open up this one as a reference that on my other monitor, so I know if I'm doing things right. And now for this shader, where I'm just going to, well, first of all, let's just take a look at what it looks like. And I think these two are both using this shader, so I'm going to open up exterior wall material, and you see the material, just basically it's just this material, and it's referencing the shader, and it's got a color input that's actually not even used. So let's find out the way to see what this looks like. You can actually look in the viewer, and I'm opening up the viewer, and if you want to, you can browse for that material file, because it doesn't just look at models, it does look at also collada files and material files. So what I'm going to do is just drag this exterior wall material file into the window, and there we go. This is what that material looks like, and it's basically just pointing to the shader, because everything is pretty much in the shader for that. So let's go ahead and edit this exterior wall file to now go to my version that I'm going to be editing, exterior underscore chops dot surface shader. And this is going to hot load, and yep, there it is. Now it's using my shader. And go ahead and close. Well, we'll keep this open for now. And then we want to look at my shader, and I'm just going to start by deleting all of these inputs and just showing you what the basics of what you need to have in your shader for it to work. So yeah, you need the open shader, the close shader, open inputs, close inputs, open code, close code, and then some of this nonsense here. This is basically just, it needs to be, oh, okay, thank you, Iron Horse. I'll talk to you later. Okay, closing chat. Sorry about that. Alright, so, yeah, you're going to need the CData thing, and then close it, and then this void material shader in material underscore input in out material. Just leave that as it is, and that's pretty much the stripped down version. And if I save this, it's just going to become empty, a black void of nothing, because there's basically what's going on is this is the shader code, which tells the game, or in this case the viewer, what to render on the material, but it's not telling it anything, so it's not going to render anything. So okay, that's starting from scratch, definitely starting from scratch here. So what I want to do, first thing we want to do is just bring in some color. So I'm going to do material.albedo equals, and then I'm going to make this is a little bit of programming. If you know what a float is, I'm going to make this a float 3, and I'm going to go 0, 0, 1, and what that's doing is it's just making this Hopefully this works. Let me see if it works before I actually do that. Okay, yeah. So this is basically just setting the albedo of this material to 001, which in this case is going to be an RBG value of 0R, 0G, and 1 blue. So if I just want a specific color, we use, in this case, percentages. So let's say if I wanted to get a specific color, I want to pick copper here. And I'm looking at this color percentage chart. So this is copper is like 72% red, 45% green, 20% blue. So I'm going to go ahead and copy that into my shader. Let's see, that's going to be 0.72, 0.45, and then this one's going to be 0.2. Save that and see if that updates my viewer. And there we go. Yeah, now I have this copper color exactly copied into basically using this percent code thing. And you can Google that and find your own source for that. It's not hard at all. And we can look at it without the lighting at just the albedo color. And you notice that normal is flat, and specular is empty, and gloss is empty, and emissive is empty. Because this is really, right now, it's just rendering just the albedo color that I defined. Okay, so typically what you want to do is not really define everything in the shader. You want to define it from the material outside and then use the shader to input that information from the material file. And that way you can have multiple material files using the same shader, and if they have different values or different textures, they're going to use those instead of, in this case, it would just be overridden by this material setting. So way to do that is it's pretty much already started. It's got this new defined thing here, color, and that's defined as these three numbers. So I'm just going to copy these numbers into here so I keep the same color, and then I want to input this in my inputs as input. Oh, I'm not doing that right. Input name equals color, which matches the name in this material file, and the type is a float 3, which means that it's 3 numbers that can use decimals. And then we're just going to close that. So that's basically not going to do, that's just basically saving this input, and in this case the input is these 3 numbers. And so then what we would do is we would change materials.albedo float 3 and just replace that with the word color, and hopefully that'll work. And it does, and as you notice, it's actually black instead of copper, but that's because changes to the material file aren't hot loaded, where changes to the shader are for whatever reason. So I actually have to close viewer and then reopen this file and drag it back in there, and it didn't change here. That was supposed to have changed. So let's see, what did I do wrong? Did I save it? I might not have actually saved it. Now we'll do it. Oh, I don't have Builder open, that's why. And I'm dragging out of my source file. That's kind of weird. So I'll open up Builder and rebuild. And I lied, I did actually have Builder open, I'm just doing this wrong. You must be doing something wrong. So let's try one more time. That's a no. Yeah, I must be doing something wrong. I'm sure someone has already figured it out, but filtering color. Dang it. This always happens. Alright. Alright. Well, shoot. I'll try that one more time. Third time's a charm. We'll just open it the old-fashioned way, and we'll open it in output. And oh, I have a copy version here. There we go. Alright, so that was it. I don't know, I guess I was opening the wrong file. I was opening the source version instead of the build version. And no big deal. Okay, so now we've got the color, and as you see here, I'm just going to go ahead and like edit this to make sure that this is actually right. So I just changed the blue value to 100%, so it should be a lot more blue once I reload this. So we did save. Where are we saving this? Yeah, we're saving this as the source, and Builder is yeah, Builder makes that. Okay. And we'll make sure that we're opening the right material type, and drag that into the viewer. Alright, close the viewer. New viewer. And there we go. Okay, so now it's like a purple instead of the copper color from before. Alright, so yeah, now I've changed it so that it's actually getting the input of the color from the material file. So, and like I said, if I had 5 different materials and they're all different colors, we would want to make sure that it's inputting the color from the material file and not defining it in the code here. However, we could do that, and I'll do that later in this tutorial, but for now we're going to create another input in the material file here. That's going to be well, I'll just call it albedo map equals materials heist. Which one? This is going to be exterior base.dds, and just to show what that is, that's this one here, and we'll just take a look at that in Photoshop. You can see that's just like a marble texture that Max must have found on it somewhere. And so we're going to be inputting that into the material file, and then we're going to have to input it here as well. So this is going to look like this. Input name equals albedo map, and quote type in this case is going to be texture, and then we want to also add address equals wrap. That's just because unique to being a texture, and then we want to close that, and then here we can change albedo to be, instead of color, because we're going to stop using the color, we're going to use text 2D. Then we're going to go albedo map, input text chord, and then close that .rgb, and that's just the basics of what you need to type in for loading a 2D texture map. Let's go ahead and save that, and that will update in the shader, but since the material wasn't loaded when this viewer model was loaded, we'll have to reopen viewer. We'll reopen this one, and there we go. Make sure that was saved. And so this is loading that material into the shader and then into viewer from the shader. Alright, so it's pretty simple, and there's some fun stuff that we can do with this. You could, if you want to stretch this out, since this is a tileable texture, we can make this double texture coordinates, which is mean that you'll have two textures wider and two textures deeper. So that's actually 4 textures in the space of the regular one-to-one space here. Or you can actually make it stretch out as well. You know, make that half. Now you have half a texture for this normal one-to-one space. You wouldn't want to do something like that for a model that has very specific UV coordinates. You really only want to do something like that for a tileable texture, if you want to. So I think we'll leave it as that. And the other thing that you can do is you can multiply its brightness basically by adding this to the end here. That'll take the color information and then make it about half of what it was, which will in turn make it darker. So you can notice how that made it a lot darker. I could also make it twice as bright by multiplying that color information by 2, and bam, now that's like really blown out. So I think the original file had it at 0.4, so we'll leave it at 0.4. And that's a basics of getting a material loaded, a 2D material loaded onto your shader. And you can add a bunch of other stuff, different types of materials. You can add a normal map. So let's say we want to add a normal map, and let's say I don't want to add it from the material itself. I want this to be consistent throughout all of the materials that use this shader. So we're just going to input here a new file called water normal map, and we're going to just copy all this stuff. And instead of closing it out there, we're going to add the file extension here, water, or the path for it here. So, I clearly typed something wrong, but I was looking at the other screen, so it's okay. And then we'll close out the input like that. And that should create a new input name called water normal map. Again, it's a texture type with wrap, so that stays like that. And then we are going to define the path to that texture in the shader and then close it. Okay. So let's just take a look at what that file looks like. Water normal maps is this one. And yeah, And so it just looks like this normal map with like ripples that doesn't really look like water, I guess, but it might look like the surface of a little turbulent water. And you'll see how that shows up in a minute. So let's say we wanted that to be our normal map for this shader. We will need to add another line here called material dot ts normal, I believe, and that will equal let's just copy this one, water normal map, and we'll get rid of this extra part here. And is that enough? That, I believe, is right. Water normal map, water normal. Okay, well, let's just try it. And that's probably going to need to reload this again. So let's go ahead and open the viewer again, open up the material and drop that in. And now we have, you can see from this angle, you can see the bumps from the normal map are showing up in the light. And if we switch over to normals, you can see them a lot more clearly. You can see the same wavy pattern. Get rid of the ground. The same wavy pattern from the texture file. So that's not actually what this is going to be used for in this material. So I'm going to take it off of the normal map. We actually don't need a normal map because in LaFauche we didn't really use any normal maps. So instead of doing that, you could delete it and not have a defined normal map. It'll basically default to this. If you don't have anything here, it'll essentially look like this. And what this is doing is just defining it as a color of, one blue, and a normal map that looks just flat. So nothing really going on there now. Okay, so I'm just going to delete this line because I don't need it, and save it again, and double check, and yeah, see the normal map is still flat. But we are going to keep this input, and there are several other materials that you can add here, like the emissive and the specular, and you can look at other shaders to get examples of that. I'm not going to go into that for this particular example, so yeah, like I said, you can go into other shaders to check that out. You can do pretty much all the same stuff to that as you will be doing with that I'll be doing with this one for the albedo map. And alright, so that's basically all that fun stuff. Now I'm going to add a new parameter here, little variable called flow, and this variable is going to equal negative time, and close that. So now I'm just I can make this float one and call it flow, and it's negative time. And then this is actually not doing anything. This is just kind of giving me this a little line of code that I'm going to use in the future. So right now I'm defining float one as flow, and that's going to equal negative time. And we'll show you what that does in a minute by adding flow to the texture coordinates of this map. So I'm just going to do add flow. So that's going to add, essentially just adding negative time. So I could just add that here if I wanted to, but that's okay. So that's basically what that does. That's going to make the texture coordinates change over time, basically going down and to the right once every second. and since it's tiling, it just continuously goes. So we don't want it to go down. We want it to, or down and to the right. We just want it to go down. So I'm going to actually make this a float 2, and then in here I guess I have to break this up into the 2 different things here. So in this case, basically, since the 2D texture I've got X and Y, and X, so I'm going to be translating that X and Y by negative time. In this case, I want X to be translated in 0 and Y to be translated in negative time. Or basically means it goes down over time. So I'll go ahead and save that, and I'm going to break something because I did not change this to float 2. This needs to be also a float 2. And there we go. So now we can see how the texture is scrolling down over time. If I wanted to, I could multiply this number by 2, and now it's going to be going twice as fast. So that's just a simple little program or line of code there that makes textures scroll fast. You can also go into this flow here and multiply it by a smaller number, and that's going to actually take, well, okay, we'll leave this as times 2, and so that's going to take this, once per second, multiply it by 2, so it's 2 times per second, and then I'm going to basically multiply it by 0.3, which is going to make it like almost a third of 2 times per second. So it's slightly slower than before. And the reason you would want to do this here is if you just in general want to change the flow value here over all of the different things that you're using that have flow added to it. So that's just basic programming stuff. So I think that's all I need for that. We don't actually want the ground texture to be moving, but I just wanted to demonstrate what that would do. So let's get rid of this line here. Let's save. We're going to add another float to called distort, and this one's going to be a texture. It's going to be using the water normal map and we're going to be putting that on there, and I add .xy here because it's really just 2D information. This is not actually going to be used as a color. We're just getting the first 2 digits, which is going to be the X and Y texture coordinate information, and then we're going to should close that out, and then I'm going to add distort to my base map here and save that. And what that's going to do is it's going to take the color information here and distort it based on that map. So it's just taking the color information and distorting it, as you can see here. So let's see. I'm gonna do here. I can add a multiplier, and I want to make this 0.3. So what this is doing is just making the distortion less obvious because this is going to be a darker color. So if I made this like 0.0 or just 0, it would basically completely go away. You wouldn't see it at all. If I made it a 1, then you would see its full effect, where it would pretty much completely override the coordinates. And yeah, extremely distorted. So I think 0.3 is what Max was using, so that's a pretty good number. I'll just stick with that. And now you can see it kind of looks like there's like a pool of motionless water like standing on top of granite, because it just had that kind of cool distortion effect that water would have. And so let's see, what we want to do is we want to add flow to this distortion effect, and let's go ahead and try that. So now you can see the water kind of distortion is moving vertically along the surface of this this stationary granite-like base map. So that looks pretty cool. That actually does kind of already got the effect of like sheets of water rolling down this stone. And I'm just going to quickly enter the basic values that he has for these. 0.3 for the flow speed, and 0.3 there for the intensity, and the base map, everything is fine. Okay, perfect. So yeah, that's just one layer. What we're going to do is we're going to add a couple more layers using a different map here. I'm just going to copy this one and paste there. Call this one color map, and that's going to go to water_color. And then I'll go ahead and show you what that looks like. It's this one here, and it is these vertical like moving lines here. Probably just was a noise map that was motion blurred or something like that, and it tiles, which is important. And we'll go ahead and close. You know, we don't need any of that right now, but that's basically what that looks like. It's just white on black. And so what we're gonna do is take that input, and we're gonna actually add on a couple new layers to this albedo map. So, well, okay, hold on. That's not what I want to do. I'm going to do this. We're going to copy this a couple times. And, well, let's just do this one at a time. So, what we want to do is add the first one to the second one. And the first one in this case is going to be the water color map, input texture coordinates, and then we want this to not be distorting, but we do want it to flow. And we'll have it flow at half speed. Actually, yeah, what was that, 0.4 speed? 0.4. And RBG, we can leave that at full brightness. And let's just see what that looks like. So this is the, it looks like I need to reload that texture. And let's try that in here. Yeah, so now we've got like this white, these white lines going down the surface of this distorted wall, and so that's pretty cool. I mean, yeah, it could use some work, but that's, you know, what we got right now. And let's add another layer to this, which has pretty much the same thing, except for this one has a flow that's being distorted. Oh, only distort. And say it's going a little bit faster. Oh, thank you, Windows, for that. unnecessary message. And okay, so we want to add distort after that. Plus flow times 0.5 plus distort. We want the distort to be fine, and we want to multiply this by 2, so it's like extra bright. And I'll go ahead and save that. Let's see what that does. There we go. So now we've got 3 different layers on just the albedo, and it's got the lines going down, and it's got this like really cool, like shimmery, distorted lines going down. So yeah, that's the basics of how this particular shader was done, and there's plenty of other cool stuff that you can do with shaders. There's probably a lot of resources you can find online about how to write your own shaders, and hopefully this is a good enough start for some people. You don't necessarily need to do anything like this, but you can certainly at least create your own shaders for all kinds of things. And yeah, hopefully that will help you, and I think that's going to be it for this tutorial. So yeah, if you have any other questions, you can email me at brian@unknownworlds.com, or reply to this video, or try and find me on the modding forums and get you some, hopefully, answer any questions that you have. So thanks a lot for watching, and see you next time.